Howdy from Yates American B244 with a new belt, a new drive motor collar and extension, and a repaired flat belt pulley. We finally see some drivetrain action. I thought I'd go ahead and give the collar a quick and dirty test. This distance will be adjusted once it's on the machine. Alright. Well, a surprising challenge that I faced on this B244 is finding a new replacement belt. They've all either been too narrow and too long, or they've been too wide and too short. So I've decided to go with one that's a little too wide and too short, and I'm going to trim the width so that it'll be more appropriate for the Reese drive pulley. So I glued up a segmented ring using some 2x4s, and then I have a backing plate of MDF. I had to put a riser block on my lathe to accommodate the mandrel, but there it is roughed out. Trimming the width of the belt involves turning it inside out and then fitting it over the mandrel and then trimming the edge of it. I've been turning on this a little bit and it's still just a little bit tight, so I'm going to reduce this diameter slightly. Okay, after a couple of iterations, I've got the belt slipping on pretty well. After experimenting a bit, I found it easier just to use a scraping tool. Okay, before you can install the motor, you have to get the Reese drive staged in this opening here. And then to get the Reese drive staged, you need to pull this transmission frame all the way up out of the way. It's a little bit squirrely getting everything in here. And then you need to put the belt on, because you cannot get the belt on after everything is assembled. And finally you can put the motor in place. And then finally, with the motor in place, the belt on, you can take the staged Reese drive and screw it in. I would advocate putting a spanner wrench on the collar and then giving the Reese drive a little snug. There. Putting Loctite on these set screws for this flat pulley. Okay, so I have this adjusted just kind of at an estimate. We'll adjust it further if we have to, but let's see how it goes. So that's the slowest speed. I was thinking that pinion and this big gear were a little noisy. Let's paint them up with some grease. Alright, let's see how it sounds with a little grease. Oh, that's much better. Now, a properly equipped shop will have one of those chain breaking tools, but this is how I'm doing it. I wanted to give you a quick comparison of the old and the new chain. So both of these chains are 101 links long. And you can see how much the old chain had stretched. It had stretched fully 3%, 3 links in 101 links. For now, I'm going to tension this chain pretty loosely because these two rollers are probably going to have to be adjusted upwards, and doing so is going to have the effect of tensioning the chain more. Okay, let's see if the whole drivetrain works now. So like I said, those upper cogs will be adjusted and that chain will get a little more tense. So let's take a look at the wheels, or the rolls. See, that's on the lowest speed, and those rolls are really moving. I don't know if there's enough light to see those upper rolls going. There's the in-feed roll. As part of testing the drivetrain, I wanted to run some stock through the machine. However, I still don't have the knives installed on the cutter head, so I don't really want to run it with the cutter head running. So I've adjusted the in-feed roll, the chip breaker, the pressure bar, and the outfeed roll like you normally would, except I've adjusted them all below the cutter head. So the idea is I want to just be able to run some stock through the machine and just see how it works. I'll run one through in high gear. Okay, I'm pretty satisfied with how the drivetrain is working. The next thing I'll do is put in some new knives and then readjust the in-feed and out-feed roll and the pressure bar and the chip breaker, and then try running some stock through it.